so there may be some coughing, but I do apologize. Hopefully we can get through this. This is chapter 1 still, linear functions, still talking about lines. And section 2, we're going to stress mainly talking about slopes of lines. Once again, this is a review for you, hopefully. You should have seen most of this. It's just a recap because a lot of this is important for the end of the year. The objective for this lesson is to find slopes of lines and to determine whether two lines are parallel, perpendicular, or neither. Okay, very important. We need to know if they're parallel lines, perpendicular lines, or neither. All right, so what do we know about slope so far? Okay, what do we remember? The first thing you should remember is that the abbreviation for slope is m. So anytime you see the m equals, you know we're talking about slope. And it has a very simple formula that you should remember: y2 minus y1 divided by x2 minus x1. Okay, a very simple formula that you need to know how to calculate the slope of a line. So for instance, if we are looking at the graph to the right, we see that there are 2 points labeled. We have -3, -3, -5, and 3, 3. Both of those points are on that line. So what we're going to do is we're going to use those 2 points to figure out the slope of this line by using our formula y2 minus y1 over x2 minus x1. So the top portion of this formula says that you subtract your y's. Now it does not matter which y you subtract first as long as you stay the same. So let's do the top point first. So we're going to do the y value is 3, and then it says to do minus, and then we're going to do our second y, which is -5. So 3 minus a -5 all over x2 minus x1. So we started with the top, so we need to start with the top again for the x's. So the x value of this top point is 3. So we're going to do 3 minus, and the x value in the second point is -3. So we're going to do -3. So this should be able to help us figure out what the slope is. Anytime you have minus a minus, it turns into plus. 3 plus 5 is 8. And minus a minus turns into plus. 3 plus 3 is 6. 8 over 6 reduces to 4 over 3. So the slope of this line is 4 over 3. So hopefully that makes sense. So a couple things we need to know about slope. We need to figure out what the slopes of all horizontal lines are. Okay, so right here I have a horizontal line that runs left to right. Let's quickly figure out what the slope is. Using our formula, we're going to subtract our y's first. Our y's for both points are 2 and 2. So we have 2 minus 2. And our x's are 3 and -4. So we're going to do 3 minus a -4. So let's figure out what this is equal to. So 2 minus 2 is 0. 3 minus -4 is plus plus. 3 plus 4 is 7. 0 divided by 7 is 0. So all horizontal lines, no matter what they are, have a slope of 0. Very important, very important. So horizontal lines have a slope of 0. Moving on to vertical lines. Okay, we have a vertical line here. It goes through the point 3, 2 and the point 3, -4. So we need to figure out what the slope of vertical lines are. So same thing, slope equals. Let's subtract our x's, or sorry, our y's. 2 minus a -4. So 2 minus a -4. Our x's are 3 and 3. So we have 3 minus 3. Minus a minus is plus. So we have 6. 3 minus 3 is 0. Hopefully you remember that you can never divide by 0. And anytime you have 0 on the bottom, our slope is undefined. So all vertical lines have a slope that is undefined. So please do not forget that. If the line goes straight up and down, slope is undefined. Next, so we have horizontal, we have vertical, now we have diagonal. So we're going to do the same thing with this diagonal line. So we're going to figure out the slope. Now this diagonal line goes down and to the right. So if it starts in the top left and goes down and to the right, the slope is going to be pretty similar. So let's figure out so first. We have to subtract our y's. So we have 3 and a negative 3. So 3 minus a negative 3. And let's do our x's, negative 3 and 4. So negative 3 minus 4. And let's figure out what this is. Minus and minus is plus. 3 plus 3 is 6. Negative 3 minus 4 more is negative 6 sevenths. So the slope is negative 6 sevenths. We're going to come back and talk about this after the next example. So this diagonal line goes from the top left to the bottom right. Okay, so let's look at the other type of diagonal line that we can have, which is from the bottom left. Goes from the bottom left to the top right. So it goes down from the left up to the right. Okay, so let's figure out what the slope of this line would be, and then we're going to talk about it a little bit. So let's subtract our y's. Our y values, this one's a little bit harder to see. It's a 2 on the right and a negative 3 on the bottom left. So we're going to do 2 minus a negative 3. And let's subtract our x's. We have a 3 on the right and a negative 5. So 3 minus a minus 5. Both of these are minus and minus, so they're both plus. The top is 2 plus 3, which is 5. And then 3 plus 5, which is 8. It cannot be reduced, so we have a positive 5/8. So the only difference between the last diagonal, which goes to the bottom to the right, and the one that goes up to the right is the sign. If you notice, if the line goes up and to the right, slope is positive. It's always positive. Okay, so if it goes up and to the right, it's positive. If it goes down and to the right, if you notice, the slope is a negative. So notice, so slope is always a negative if your graph goes down and to the right. Okay, so just to recap really quickly, we had horizontal. Horizontal lines always have a slope of 0. They're completely flat, so there is no slope, or it has a slope of 0. Vertical lines have no slope. There is no slope on a vertical line, so that is why we say it's undefined, or if you would like, you can write no slope. If the graph goes down and to the right, the slope is always negative. Slope is always negative. And if the graph goes up and to the right, slope is always positive. Slope is always positive. Okay, so hopefully that's a little bit of review for you. Hopefully you remember that. Very important stuff. All right, so let's try example 1. It says, what are the slope and y-intercept of the equation? So let's not forget our slope-intercept form from the last section. Y equals mx plus b. And remember, m is your slope, b is your y-intercept. So we need to put it in y equals mx plus b form first in order to find that out. So we're going to go over to our equation, and we are going to solve for y because that's what slope-intercept form says. So I'm going to subtract 7x on both sides. 7x minus 7x is 0. 14y equals, bring down the negative 7x first, bring down the 28. Then we have to divide by 14 to get rid of the times 14, so we divide both sides by 14. And 14's go away because that's 1. So y equals negative 7 over 14 is negative 1/2. X plus 28 divided by 14 is 2. All right, so what does this mean for us? It wants to know what is the slope and what is the y-intercept. So slope is the number in front of the x. So the slope is negative 1/2, and the y-intercept, or the b value, is the number after the x, so it's positive 2. So there's our two pieces of information that we needed to gain for this example. And we'll talk about how to graph later, probably during class, so you don't have to worry about that right now. And lastly, we have two more things we need to talk about. We need to talk about parallel lines, and we need to talk about perpendicular lines. So let's look at parallel lines first. So we're going to figure out what the slope of these two lines are first, and then we will talk about it. So let's do the blue line first. So m equals, so first remember, the y's are on top. So we have a 1 and a -2. So we're going to do 1 minus a -2. Then their x's are 2 and 4. So we're going to do 2 minus 4. Okay, so let's figure out what the slope is. So minus and minus is plus. 1 plus 2 is 3. 2 minus 4 is a -2. So slope equals -3/2 for the blue line. Okay, now let's figure out the slope of the red line, which is, so let's subtract our y's first. So we have 1 and a -2. So 1 minus a -2, and then we have -1 and 1. So -1 minus 1. So we have plus plus. 1 plus 2 is 3. -1 minus 1 more is -2. So what do we notice about parallel lines? What do we notice about parallel lines? As you can tell, their slopes are the same. So very important. Parallel lines, slopes are equal. Very important, very important. Slopes are equal in parallel lines. And that works for all parallel lines no matter where they're located. And lastly, let's look at perpendicular lines, and we need to figure out what kind of slopes perpendicular lines have. So alright, so we have perpendicular lines here, and we are going to figure out the slopes of the two perpendicular lines. And let's figure out the green slope first. So our y values are 3 and 1. Our y values are 3 and 1. So let's do 3 minus 1. And our x values are -7 and 2. So -7 minus 2 to give us a slope of 3 minus 1 is 2. -7 minus 2 is -9. So the green line has a slope of -2/9. Okay, now let's figure out the slope of the red line, which is, the y values are 5 and -4. So 5 minus -4, and the x values are -3 and -5. So -3 minus -5 to give us a slope of plus plus, minus minus is plus plus, to give us a slope of 9 on top, and we have plus plus on the bottom. -3 plus 5 is 2. So we have a slope of 9/2. So what do we notice about these two slopes that they have in common? Okay, so first thing we have in common is one is a positive and one is a negative. So one's a negative, one's a positive. So they have opposite signs. Okay, that's one thing. And they're also, one is 2/9, the other one's 9/2. So they are also reciprocals of each other. So perpendicular line slopes are opposite signs and they are reciprocals of each other. So that about does it. That is chapter 1, section 2. Thanks for watching, and I'll see you tomorrow. Bye.